Continuing our lesson on annuities. So we have different kinds of vehicles that we talk about. Loans. So loans are what we borrow when you borrow money. We borrow a lump sum of money and then pay back the principal plus accumulated interest. And we have income funds, some type of investment. So you invest some money to provide you with a regular income payment. And so either a loan or an investment, we can use our annuity formula to help us problem solve. Now, I'm going to talk about the present value. Again, present value, similar to compound interest, is that P. Think of the capital P value, the amount of money we need today, present value. So the amount of money we need today, that if you invest that money today, it will grow into the amount of money you need in the future. Or you can also think of it as what is the that value of some product or object that you may have value in the future, but it's certain value has a certain amount of value that it's worth today. Okay, so problems like that, when you look about amounts of money we needed today, we'll explore that in the next couple of problems. But here's the formula: if you rearrange the future value formula, you can rearrange it for the present value, or rather, let's just describe the present value using a formula that's very similar to the future value. It's just P equals R. The brackets are 1 minus, round bracket again, 1 plus I to the exponent negative n. So the exponent is now negative, and so 1 minus the bracket instead of the bracket minus 1. And then we divide that by I. So very similar, but just slightly different. So P will refer to my present value. Okay, R is still the regular payment. I is still the interest rate that's compounded. And N is the number of compounding periods. So example 3, Bob bought a used car and paid for it in monthly installments of $400. The car dealer charges 8% compounded monthly. What was the purchase price of the car? How much interest did Bob end up paying? So we're not looking at how much, we're not looking at like a loan value 5 years from now or however many years from now. We're looking at the interest, we're looking at the value of something today. What was the purchase price of the car? What was the price of the car he purchased the car at today, or the day he bought it? Okay, at the very beginning, in other words. Present value means the beginning. Okay, well, every time we look at finding A in the past, that was the future value, right? At the end. Here's the value of the thing at the beginning. So the regular payment is $400. Okay, in monthly installments. My number of compounding periods. So the question doesn't specify how many years, so I'm going to arbitrarily, it's going to add it in there. Let's just say for 5 years. So for 5 years, n is 5 times monthly compounding means 5 times 12, 60 payments in total. Okay. My interest rate is 8%, so 0.08 is a decimal. Divide that by 12 because it's compounded monthly. And then I can calculate the present value. So how much did he paid $400 every month to pay off this car. There's some interest in there. Okay, so after 5 years, the car was paid off. Okay, we don't know how much he paid in total, but we do know how much he paid in total. He paid $400 times 60 payments. Sorry, monthly installments of $400 times 12 times 5. Yeah, times 60. That's right. So that's a total of $24,000. He paid $24,000 total for this car over the 5 years. So some of that $24,000 was interest, and the rest was the original amount of the car. Okay, so what was that original amount of the car? What was that present value? So you say 24,000, some interest plus the PV makes up that 24,000. Okay, so present value. So P equals R, 400 times 1 minus 1 plus interest rate, 0.08 over 12, raised to the power of negative 60, that's the n value. All of that divided by I, 0.08 divided by 12. Okay, so again, as you're calculating this, do this in your calculator, but don't write it down, don't round it at all. Then you add it to 1. Okay, and after you add it to 1, take it to the exponent negative 60. You get some number in your calculator, then do 1 minus that number. So 1 minus answer. The 1 minus answer button will be tremendously useful when you're doing that calculation. Then multiply that result by 400 and divide it by 0.08 over 12. Put it in brackets as you're doing it in the calculator. Okay, so I'm going to just take a quick moment to do this on my calculator. So 0.08 divided by 12, add 1, take it to the exponent negative 60, 1 minus my answer button, and then multiply it by 400. So the top number is going to be here is 131.5158222. You know that's going to keep going, right? And then you divide that 0.08 over 12. So don't round any of this. Just keep all that in your calculator. Divide by 0.08 over 12. And then the final answer you can round. So here it is, $19,727.37. So the price of that car, the purchase price of that car was $19,727.37. That's your purchase price. But Bob didn't have the money to purchase it, so he borrowed money. So he borrowed money and he paid that $400 monthly installment. So he paid $24,000 in total. So the difference between $24,000 and $19,727, that's the interest. So the interest that Bob paid. Now, although the question, so the first part of the question was answered, purchase price. The interest he paid is the total amount of money he paid, $24,000 in those monthly installments, minus the purchase price of the car. And that is an amount of interest of $4,200. So 24,000 minus 19,727. He paid $4,273 worth of interest. Okay. Example 4. Mrs. Snyder had $17,000 in Ontario student loans when she finished university. The government charges 8.5% compounded monthly. What is her monthly payment if she wants to finish paying off the loan in 2 years? She wants to know how much she has to pay if she wants to pay it off in 2 years. So what is R? Okay, for N, it's going to be 2 years. If it's compounded monthly, 2 times 12. She wants to pay this loan off in 24 payments. Okay, the interest rate is 8.5%. So this is going to be a little bit new. Maybe you saw this in your homework. 8.5%. If the percentage is already decimal, you still have to convert it. Divide it by 100. It's going to be 0.085. Compounded monthly, divide that further again by 12. Okay, so again, that's the number you're going to keep in your calculator because it's a repeating decimal. But now let's calculate present value. So PV, present value, 17,000. Oh, let me write this down. Present value, P is 17,000. She graduated and the starting value of the money she owed was $17,000. Okay, so how much does she pay to pay off that $17,000? So let's write down the present value formula. P equals R times 1 minus 1 plus I to the power of negative n, include all those brackets, divide by I. So if I was interested in solving for R, I have to rearrange the formula. So if I multiply both sides of this formula by I get P times I equals R times 1 minus 1 plus I to the power of negative n. And if I move the entire square bracket on the left side, I can say P times I divided by the square bracket, 1 minus 1 plus I to the power of negative n. I can get R isolated, and that will give me my solution for R. So up here, let's write this. R equals P, which is 17,000, times my interest rate, 0.085 over 12, divided by 1 minus 1 plus, in brackets, 0.085 over 12, so the power of negative 24, close the square bracket, evaluate this, and then if you evaluate this, you should get roughly $773 per month. Okay, so for $773 per month, how many payments is she making? 773 times 24 payments. All in all, she's paying a total of $18,552 of payments. So her loan is only $17,000, but the interest, the difference between $18,552 and $17,000, that's the interest. So about $1,552 of interest. And that's the reality. If one day you get your own student loans to pay for university. Anyways, that's the end of this video.